Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic area. And for this lesson, we are going to cover applications of area of a sector. We previously covered area of a sector, and we were able to see how we are able to find the area of a sector. Now we want to see how this is applicable in real life. So we have a few questions that are going to help us with illustrations on how to how to solve problems involving area of sector. At the end of the lesson, we'll be having some assignment just to help you practice and also just to help gauge on your understanding of the concept as discussed. So as we said previously, a sector is basically a region bounded by two radii and an arc of a circle, as you can see. So with the two of them, we have the major sector and the minor sector. So major sector is the area that is more than half the area of the circle. Minor is the area, this one, the sector whose area is less than half the area of the circle. Formula used for finding the area of a sector, whether major or minor, is theta over 360 times you multiply by the area of the circle, which is pi r squared. It's just, we said a sector is just part of a circle, so its area as well is just a fraction of a circle, and the fraction is given by the formula theta over 360 here, which is theta is the angle subtended at the center of the circle. Okay, so let's see some of the questions involving applications of area of a sector. So we have the length of a minute hand of a clock, which is 3.5 centimeters. You're supposed to find the angle it turns through if it sweeps through an area of 4.4 square centimeters. So we'll still use the formula. So we'll still use the formula A. So A here is equals to theta over 360 times pi r squared. So A is given 4.4. This is equals to theta is what we are trying to find over 360. You multiply by pi, which is 22 over 7. And then radius, which is 3.5 by 3.5. So if you want to find the value of theta, what you'll do is to multiply the left-hand side of the equation by the reciprocal of all this that you see here. This can be written over 1, as an improper fraction by the denominator of 1. So 3.5 over 1, 3.5 over 1. So you'll multiply 44.4 the other side by that reciprocal there. So that means we have theta then equals to 4.4 multiplied by 7 times 360. And then you divide by 22 by 3.5 by 3.5. So now we can try to cancel or simplify further. So 7 here once, 7 here 0.5. 22 will go here 0.2. 22 here once. So what else is there? So 5 maybe. So 5 here 0.7. 5 here 7, 2. And so now we have 0.2 times 72 over 0.5 times 0.7. So you multiply both numerator and denominator by 100. 10 will be used to remove the one decimal place at 0.2, and all this will be used to remove these decimal places. So we will have then our theta equals to 2 by 72. You divide by 35. Because there is multiplication by 10. There was 10 remaining up there. So if you multiply that, we get 1440 over 35. And if you use the long division method to do that, what will you get? See? Maybe you can simplify further. We can have maybe 5. 5 goes here 7 times. And 5 goes into this. 2 because of 10. Remainder 4, 44. 8 because of 40. And then remainder 4. So 40 again. 8. So what we have remaining then is 288 divided by 7. So if you had to use long division method to simplify this, we have 288 and we are dividing by 7. So you'll have 0, 0. I'll just go up to the fourth significant figure, then I stop. So 7 goes into 28 4 times, and 4 by 7 is 28. So that is 0. So I'll just drop 8 down here, because if you subtract this, it will be 0. 7 goes into 8 once. 1 by 7 is 7. You subtract this is 1. You drop the next 0 down here. 7 goes into 10 once. 1 by 7 is 7. You subtract this is 3. You drop the next 0. 7 goes into 30 4 times, and 4 by 7 is 28. You subtract this is 2. You drop the next 0. So 7 goes into 20. How many times? 2 times. 2 by 7 is 14, and you can stop there. So the decimal point will jump up there. This is 6. So 41 point. So you have our theta is going to be 41. 41 point what? 0.14 degrees. So the two arms of a pair of divider are spread so that the angle between them is 45. Find the area of the sector formed if the length of each arm is. So you have some center here. And then you have one arm of a divider, that one. And then you have another arm. This one here. Then the angle between them is 45 degrees. So the length of this is given as 7 degrees. So you are basically supposed to find the area they sweep through. So the area here will be given by theta over 360 times pi r squared. So theta is 45 over 360. You multiply by 22 over 7. And the radius is 7, another 7. So you simplify. So 7 here, 1, 7 goes there once. So 5 here 9 times, and 5 goes into this. 72. So what remains now? Maybe 2. So 2 here 36. 2 there 11. There is still 3. So 3 into 9, 3 times. 3 into this, 12 times. 3 into this once, 3 into this 4. So that means in the denominator we only have 4. You only have this remaining. This one here. But up there we have 11 and we have 7. So it means what we are trying to find is 77 over 4. there any of them that you have left up there? No. So you can use long division method again. So 4 is here, 77 is there. You add as many number of zeros. So 4 goes into 7 once. 1 by 4 is 4. You subtract, this is 3. Drop 7 down here. 7 goes into 37. 4 goes into 37 how many times? That is 9 times. 9 by 4 is 36. So the difference is 1. Drop the next 0 here. 4 goes into 10 too. 2 times 2 by 4 is 8. 2. You drop 0. 4 goes into 25 times. 5 by 4 is 20. So 0, 0. And then the decimal point will jump up there. So what you're looking for should be 19.25 square centimeters. So we have a final example here on applications. So find the difference between the area swept out by a minute hand of a clock, which is 3.5 centimeters long, and the hour hand of a clock, which is 2.9. Actually, this is supposed to be let me change this to 0.7. Maybe 2.1. So the hour hand of a clock, which is 2.1 centimeters long. So now, how do you go about it? So just the same thing we did. We have the center here. Then we have the minute hand there. And we have the hour hand. So this is the hour hand. So the minute hand will sweep through this area, but the hour hand will sweep through this area. So basically the area we are trying to find is that one there, the one that is shaded. So this length is 3.5 and this other one is 3.5. So the area that is, 2.1. So this is 2.1. So the area swept out by the hour hand will be the area, the unshaded area, this area here, the one that is not shaded. The one that is swept out by the minute hand, so hour hand 2.1, minute hand 3.5. So we find the two areas and we subtract the whole area minus the area of the unshaded. So let me call it AT, which is A minus A. So A is the total area. So that is going to be, again, theta over 360 times pi r squared. So let me do it here again. So what's theta? 60 degrees. They swept, given that they both swept through an angle of 60 degrees. So this angle here is 60 degrees. So you divide by 360, 22 over 7 by 3.5 by 3.5. Okay. So 60 here, 160 goes there 6 times. So what else remains? So 7 here, 7 goes there 0.5. 2 here 3 times, 2 there 11. So I'll multiply 11 by 0.5 by 3.5 and then I will divide the answer by 3. So let me try. So I'll just multiply 11 by 5 and 11 by, and the answer by 35, and then I have 2 decimal places. So 11 by 5 is 55, and then you multiply by 35. So 5 by 5 is 25, carry 2, 25, 27, 0. 3 by 5 is 15, 5 carry 1, 15 and then 16. Top up the space left using zeros, multiplication, addition. So this is 5. This is 2. Carry 1. So this is 9 and this is 1. How many decimal places were they? 2. So this is where the decimal point should be. Square centimeters. Now A, which is the area of the unshaded region, again that will be 60 over 360. You multiply by 22 over 7 times 2.1 times 2.1. So again, as we did with the larger area, 60 here, 160 here, 6 times. 7 here, 1, 7 there, 0.3. So 2 here, 3 times 2 there, 11. So again, 11 by 3 by 21, and then the answer you get, you will divide by 3. Actually, this answer here is supposed to divide it by 3. So let's divide it by 3 first. So let's divide that answer by 3 first. We multiplied, supposed to divide. So let me do the multiplication bit first, then I'll do the division on the other side. So I have 60 over 360. I multiply by 22 over 7, and then you multiply by 2.1 by 2.1. So 6 here, 1, 6 here, 6 times, 2 there, 11, 2 here, 3 times, 6, 7 here, 1, 7 there, 0.3. So 11 by 0.3 by 2.1. So 11 by 0.3 is 33. So that is, I'll just multiply the numbers and then the decimal points, I will include them later on. So 11 by 3 is 33, and then 33 by 21. What is that? So 1 by 3 is 3, 1 by 3 is 3. 2 by 3, 6, 2 by 3, 6. Multiplication, addition, 3, 9, 6. How many decimal places? 2. So it's 6 point. So now we need to divide both of them by 3. So let me start with 19, 19.25. So 19.25. Then you are dividing it by 3. So 3 goes into 19 6 times. 6 times, and 6 by 3 is 18. Subtract 1, drop these 2 here. 3 goes into 12 4 times. 4 by 3 is 12. So just drop the next 5. 2 goes into 5 once. 1 by, 3 goes into 5 once, and 1 by 3 is 3. After this, you can add as many number of zeros as possible. So you'll drop this next 0 here. So 3 goes into 26 times 6 by 3 is 18. So again 2, you drop the next 0. So that is going to be 6, 6, 6, 6, 6. So what is that? So it means my capital A should be equal to, because the decimal point will jump up there, should be equal to 6.417 square centimeters. So we rounded off. The number after the cutoff line falls in the upper category, so you increase this 6 by 1. That's why it becomes 7. Now the same applies to A. The 6.93 we'll have to divide it by 3. So again 6.93. We divide it by 3. So 3 goes into 6 2 times, 2 by 3 6. So we just drop 9. 3 goes into 9 3 times. 3 by 3 is 9. 3 goes into 3 once. So that is exact 2.3. So A is 2.31. So A minus A should be 6.417 minus 2.310. So 7014. So the area that we are looking for is 4.107 square centimeters. So that is how you go about it. So we have a few questions to help you with practice and just to help you check on your understanding of the concept as discussed. Otherwise, that is all for now. Till next time, goodbye.